Okay, Algebra 1 fans, our topic for today, this is Unit 7-1, Multiplying Monomials, Day 1. We're going to take a few days on this topic. So before we start, let me give you your joke of the day. A slice of apple pie is $2.50 in Jamaica and $3 in the Bahamas. These are the pie rates of the Caribbean. Pie rates, pirates, okay. So our goals for today, number 1, expand exponential expressions, and then the second goal is to multiply monomials using the laws of exponents. So the first thing we're going to talk about, expanding exponential expressions. To expand means to write out. So for example, x raised to the fourth, when we use an exponent, that means that we multiply this value, whatever it is, times itself 4 times. So the exponent tells us the number of times that we multiply that value by itself. Now this number or variable at the bottom here is called the base. And then the small number to the right and a little bit higher is called the exponent or power. Now there are a couple ways that you can read this. We can say x raised to the fourth, x raised to the fourth power. We could say x to the fourth as a short way. That's often how we're going to do it, x to the fourth. Okay, so the base is the number that's going to multiply, and the exponent is the number of times we multiply that base by itself. So if we use numbers, for example, if I say 2 raised to the third power, the base is 2, and I'm going to multiply 2 by itself 3 times. Okay, so now this is not 2 times 3. This is not equal to 6. It's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. Okay, so you need to be careful when you do this because it's not multiplying by the exponent. It's multiplying the base by itself. And the other thing you need to be careful about, if I say -3 raised to the second, that's -3 times -3. And a negative times a negative is always a positive number. If you are using a calculator, and if I type -3 raised to the second, like that, I am going to get a negative value, which is wrong. The reason why is that the way I'm typing it is I'm only squaring 3, then I'm multiplying by -1. If I want to square -3, I need to put -3 in parentheses, then raise it to the second power. That's going to do -3 times -3, which is 9. Okay, so example number 1, expand 3 squared. Okay, and that's the other thing is when we raise it to the second power, we use the term square. When we raise a base to the third power, we use cube. Okay, so if the exponent's of 2, we say square, and if the exponent's of 3, we say cube. And then y raised to the fifth. So we're just going to write it out. 3 squared is 3 times 3. X to the third is x times x times x. Y to the fifth is y times y times y times y times y. Now this is all multiplication. So when we have a number here next to a variable, next to the x to the third, next to y to the fifth, we don't put the time symbol in there, but that's what's happening. You are doing multiplication. Okay, now one other thing before we go to more examples here. It says multiplying monomials. Mono means 1. Okay, monomial is basically a term, one term, with some combination of variables and exponents. So for example, 3x to the fourth, that is a monomial. If I said x to the seventh, y to the fourth, z, that is a monomial. So some combination of either a number, a variable, or a product of a number and a variable. And to get specific, a monomial does not have, we're not going to write it with square root or anything like that. Okay, so let's take number 2 here, simplify the following expressions. Well, this is expanded. Now we want to write it in exponential form. A times A times A times A times A times A is A raised to the 6th power. So it's a lot easier if we write this using exponents. It means the same thing. Here we have 2 multiplying 3 times, so we can write 2 raised to the 3rd. And we have x multiplying itself 5 times. That's x raised to the 5th. Now, one thing we can do with numbers, if we have a number for a base, 2 raised to the 3rd, we can simplify that and write that as 8x to the 5th. Okay, so that's the way we want to write that. Okay, a to the 6th, 8x raised to the 5th. Now, let's say we multiply monomials. X raised to the 2nd times x raised to the 3rd. If we expand, x squared is x times x. X cubed is x times x times x. Now we can count this, 1, 2, 3, 4, 5, so that equals x raised to the 5th. And that's our answer. X raised to the 4th times x raised to the 7th. So we can expand again. That's x to the 4th. X to the 7th. 5, 6, 7. Okay, now if we count this up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, we get x raised to the 11th. Now you might be asking yourself, is there an easier way to do this? And the answer is yes, there is. You may have already noticed the pattern. When I'm counting these up, I have x 4 times and then x 7 times, and I have a total of 11. Here I had x 2 times x 3 times. That was a total of 5. So there's a rule, this is what we're going to learn, is that when you multiply the variables, you can add the exponents. That's a short way to do it. So for number 6, I'm actually going to do x. 6 plus 10 plus 2 is my exponent, which is x raised to the 18th power. So that's the shortcut. Now, if I wrote it out, I would write this x 6 times, then 10 times, then 2 times. 6, 10, 2 adds up to 18. So here's exponent rule number 1. This is called a product of powers. A raised to the m times a raised to the n is a raised to the m plus n. So basically what happens is we keep the base. The base is a. We write that down, but we add the exponents. Okay, that's the rule right there. Product is multiplication. So when we're multiplying variables, we keep the variable, we keep the base, and we add the exponents. Okay, so let's do some examples. Directions, simplify the following expressions. All right, so for number 7, a raised to the 6th times a raised to the 8th times a raised to the, that is a 1. That's a raised to the 1st. I like to put that number in there so I don't forget about it. And we keep the base. When we multiply the variables, keep the base, add the exponents. So 6 plus 8 plus 1, and we get a raised to the 15th power. And that's it. Number 8, 4c to the 6th times 5c to the 3rd. Now remember, this is multiplication. So for the coefficients, okay, the number in front of the variable, those are called coefficients. We multiply those. Okay, we don't add those up. That's not 4 plus 5, it's 4 times 5, so we get 20. C to the 6th times c to the 3rd, we keep the base, we add the exponents. So we get 20c raised to the 9th power. Now number 9, okay, when you have parentheses next to parentheses, that's also multiplication. Now you don't need to do this, but I'm going to write it out with a little time symbol. multiply the coefficients. 8 times 3 is 24. Now when we multiply x's, we keep the base, keep the x, add the exponents, and we get 24x raised to the 6th. Now when you do this, you don't have to write 4 plus 2. You don't need this step. You can do this in your head. But for these first couple problems, that's what I'm going to do. I'm going to write it out. I'm going to show my work. Okay, so flip it onto the back. So let's take the next one, number 10 here. So we've got 8y. We've got a longer problem here, parentheses times parentheses times parentheses. Let me write this out. So 8y to the 3rd times negative 3x squared, y squared, times 1/4. That's x to the 1st, y to the 4th. Now the first thing I want to do is I want to take my coefficients. 8, negative 3, 1/4. I'm going to multiply those. Now I can multiply in order. 8 times negative 3 is negative 24. And in this case, when I multiply by the fraction, that would be negative 24 divided by 4. So we get negative 6. So the coefficients multiply to negative 6. Now we have two variables. We have x's and y's. Let's go in alphabetical order. So the x's, we have x to the 2nd times x to the 1st. When we multiply variables, we keep the base, add the exponents. Now for the y's, we're going to keep the base, add the exponents, 3, 2, and 4. So our answer is negative 6, x raised to the 3rd, y raised to the 9th, and that is as far as we can go. You know you're done when you only have a variable written one time. Okay, so we've multiplied all the coefficients, we've combined the variables by adding up their exponents, and that's it. Number 11, so negative 18 x to the 4th, y to the 3rd, z to the 7th times negative 4, that's x to the 1st, y to the 2nd, z to the 1st. Okay, again, I like to write those exponents. Okay, negative 18 times negative 4. Negative times a negative is always a positive number, that's 72. Multiply variables, we keep the base, add the exponents, 4 and 1. For the y's, y to the 3rd times y to the 2nd, 3 plus 2. Z to the 7th times z to the 1st, 7 plus 1, equals 72. X raised to the 5th, y raised to the 5th, z raised to the 8th. This is not hard to do. It's not hard calculation, but you have to be careful. You have to go one piece at a time. And if you make one little mistake, you've just got the problem wrong. Okay, so that's the thing. You need to be systematic. Go step by step. Let's do two more here. Number 12, 4x raised to the negative 2 times 1/2 x raised to the 5th. So this time, 4 times 1/2 is 2. Half of 4 is 2. It doesn't matter that the exponent is negative. When we multiply variables, we add the exponents. So that's 2x. Negative 2 plus 5 is 3, so 2x raised to the 3rd, or 2x cubed. And then number 13. Okay, so one thing you can do if you want to start skipping a step here, I'll take the x's, I'm going to circle their exponents. We're going to add these up. 3 plus negative 1 is 2. 2 plus 5 is 7, x to the 7th. When we multiply the y's, let me use a different color here. 2, 6, negative 2. Add the exponents. 2 plus 6 is 8, plus negative 2 is 6. So we have x to the 7th, y to the 6th, and that is the end of part 1.